question that I want to talk about is evolution. Someday, when you'll get into Gemara good, the Talmud, you'll see that the whole discussion of evolution is very much like a piece of Talmud. People don't agree on the definitions of the concepts. They don't agree on what the rules are. They don't agree on what the experiments say. They don't agree on what's evidence for, what's evidence against. It is a gigantic mess. It's a gigantic mess. Not at all like astronomy, not at all like geology, not at all like material science, not at all like metallurgy. No, I think there's a symptom of this being a very immature science. But let's take a very simplified version. I want to express to you one objection which has been made over and over again, been made very forcefully recently. I have I think a very intuitive way of putting the objection, though it's not mine. And it's an objection to which no one who believes in evolution has even suggested an answer. They haven't even suggested an answer. The way evolution is supposed to work, again, this is very simplified, is this. Imagine something that makes copies of itself. It makes copies of itself. That's pretty complicated. It's more complicated than a toaster, or than a washing machine, or a VCR, or your personal computer. Even more complicated than Deep Blue, which won a game from Garry Kasparov and world chess champion. It's a very complicated thing that makes copies of itself. And it's very good at making copies of itself. Very good, but not perfect. Very good, but not perfect. Not always are the copies exactly accurate. So now, here's what happens. It's making copies, busy making copies. And of course, if it makes a copy of itself, then the copy is also going to make copies of itself, because it's a copy of a thing that makes copies of itself. Yeah, we got that? Okay. So now you got them, churning out copies. They get more and more of them. But once every 1,000 copies, it's a glitch. It makes a mistake. Now, if you have a thing that makes copies of itself and you get a glitch, chances are it's going to go to pieces. This is a very complex, tightly organized, integrated mechanism that does a very sophisticated job. Imagine taking your iPhone and going to the basic code and taking the whole line of code out and putting in a line for the telephone book. What's going to happen? I think it's going to crash. The telephone doesn't belong in the basic code of the iPhone, right? Of course, the iPhone's written in that code. Just switch it or erase some symbols or put in some other symbols. It's going to be terrible. But by accident, 1 in 1,000 glitches will end up improving the ability of this thing to make copies of itself, which means 1 in 1,000,000 copies is going to have that improved ability, right? 1 in 1,000 gets a glitch, and 1,000 glitches gets you an improvement. So here they are. Let's call them the A's. The A's are busily churning out more and more A's, and then from time to time they get a glitch, not just dies, and they get churning out more and more until you get a glitch, which is an improvement. Call that one A star. Okay, now A star is a little better, a little faster. It can make copies in a wider temperature range. Its copies are more sturdy. They last longer. Well, you're in an environment with limited resources, and A's and A stars are now competing for the resources, and the A stars are better at making copies. That's going to set up competition, and goes on long enough. Nothing's permanent. An A that's copied eventually is going to break down into its components to be reused, reshuffled, and the A stars are going to take over until what do you think? Until 1,000,000 steps down the road of the A stars multiplying, there's going to be a glitch which improves, and you get a double star. A double star is a little better than the A stars in making copies of itself. So now you got 3 on the scene. Pretty soon A's are going to wear out. They're just going to disappear. A star versus A double star, and they're going to keep churning away till you get A triple star, and quadruple star. That's it. That's the scenario. That's where butterflies come from, and redwood trees, and porpoises, and fungus, and everything. Bacteria, it all comes from that mechanism. Copies, glitches, accidental glitches, unguided, unplanned, uncontrolled, unfocused, just accidental. Why? A cosmic ray hits the DNA and causes it to glitch. There's an attack of an acid. The temperature changes. Some instability causes a failure of copying. And then by accident, eventually, you get an improvement. That's where it all comes from. Okay. I have one question to ask. My question is, what's the probability of it happening that way? What's your estimate of the probability of it happening that way? The reason I ask that question, I will explain to you with a parable. Then I'll come back and I'll apply it directly to this. I have an object, and I have painted on one side of the object an X. Now I tell you that I took this object and I threw it into the air 3 times, and it landed on the X 3 times in a row by accident. I didn't throw it in any specific way. It's not weighted on one side. It's not magnetized. Doesn't have fluted edges that catch the air currents as it goes up and spins around to land on that side. It's perfectly symmetrical. And I threw it up, and by accident, it landed on the X 3 times in a row. Do you believe me? Well, some have nodded their heads yes. A couple nodded their heads no. I haven't heard the right answer yet. Why don't you know? Because I said yes and no are both wrong, so he doesn't know. The answer is, I haven't given you enough information to make up your mind. What piece of information have I suppressed so far?
Evidence? What's the other side?
How many sides does the object have? Maybe you thought it was a coin. Then the probability is 1 in 8. That's not outrageous. That'll happen, 12.5% of the time. But I didn't tell you how many sides it has. Suppose it has 1,000 sides. So then it's a 1 in a billion chance. Should you believe it if I say I've got 1,000 sides, one side has an X, I threw it into the air and accidentally it landed on the X 3 times in a row? Surely not. If it's a coin, it's perfectly all right to believe it. If I refuse to tell you how many sides it has, what should your response be? You haven't given me enough information to make up my mind. It's not reasonable to say yes or no. Anything that's supposed to be produced by an accidental, uncontrolled process, the key thing you want to know is, what is the probability of your proposed explanation, your proposed process of producing this result? If he can't give you an estimate of the probability, then he hasn't got a hypothesis that's detailed enough to make up your mind on. So the key question for our friends who believe in evolution is, what is the estimate of the probability that the process you are describing gave this result? What's the probability? They haven't got a clue. Francis Crick, now I'm going way back into history, in 1885 wrote a book called Life Itself. And he says in that book, the probability that life on this planet came into existence, developed and diversified according to the theory of evolution, could be 0 or 1 or any fraction in between. There's no way to estimate what the probability is. Nothing's happened in the last 30 years to change that. Indeed, the evolutionary community has been challenged repeatedly. Give us an estimate of the probability. No one has even tried. Thomas Nagel's latest book, Mind and Cosmos, published by Oxford, lays down the challenge, as everyone has before him. There's no estimate of the probability. There's no reason to think the probability is anything but vanishingly small, even given billions of years. Even given billions of years, there's no reason to think that the probability of life evolving into the envelope of life we see today by the process of evolution in 4 billion years, that the probability is anything but vanishingly small. No reason has been given to think that the probability is reasonable, the estimate is high enough to take seriously. Well, if that's the case, I think what we ought to say to the believers in evolution is, you haven't given me enough information for a reasonable person to make up his mind. I'm not saying you're wrong. I'm just saying there isn't adequate reason to say that you're right, to accept it as true. Now, I recommend to you that you try this out. You have believers in evolution, including your evolutionary professors of evolution. Write this to them and ask them. Tell me where you get an estimate of the probability. One response that you get when you ask this question is this. What you're asking for, is it possible? It's really impossible. Look, evolution, we say, took place through thousands, tens of thousands, millions of mutations from the first self-replicator, which was probably a molecule of some kind, to elephants and mosquitoes and orangutans and albatrosses, and it's going to take millions and millions of mutations. What do you want? I should estimate the probability of each mutation, and those mutations took place over billions of years, where the environment was very different, the temperature was different, and the atmosphere was different, and the seas were composed differently, and all the rest. You're asking for something impossible. Okay, suppose I am. Suppose I'm asking for something impossible. So then they go, well, it's not fair, you know. You can't ask for impossible things. I said, well, why not? I mean, in order for me to be convinced that what you say is true, you have to provide a probability. If you can't provide a probability, if getting a probability is impossible, then I guess it's going to be impossible to take what you say seriously. It's just going to be impossible. The fact that it's impossible doesn't mean I should accept it without a probability. That doesn't follow. What follows is that it's going to be hard to ever take you seriously. It's going to be hard to ever take you as if you have a hypothesis that's worthy of belief. So if it is impossible, too bad. It could be a research program, and you can perform your experiments and your computer simulations and all the rest, but to take it seriously as correct, why should I do that? I think that's absolutely crushing. It's absolutely crushing. Doesn't show that it's wrong, but it shows that they don't have, and it's not likely that in the near future they're going to have, a probability that will make it capable of judgment, capable of evaluation to take seriously. Are we together? Okay, now just one footnote on that, and we can move to other things. There have been people who have pretended to make a probabilistic estimate and say the probability is so low that we should rule it out on the basis of the fact we know the probability is very, very, very low. Mathematicians in particular have been into this idea that we should use mathematics, advanced mathematics, to test the viability of theories. The trouble with the mathematical estimates, similar now to what Maimonides said, is that you have to have details about how the process works. You can only give a probabilistic estimate if you know how it works. At this point, the believer in evolution can always fall back on the idea that there are hidden processes that we're not aware of, that haven't discovered yet, which make it much more probable. Stuart Kauffman of the Santa Fe Institute, who believes in self-organization, because it's been found in chemistry, and he wants to suggest that there are principles of self-organization throughout nature, and they will make it possible to overcome these probabilistic hurdles. Right? Well, maybe there are, and maybe there aren't. He hasn't proposed any, hasn't found any. He's just pointed out that it's certainly possible that there are, and so let's look for them. And I applaud. Go ahead, by all means, let's look for them. And when you find some, we'll take them into account. But in the meantime, the use of probability is hamstrung. It's cut off on both sides. They can't give us a probability that's big enough to take the thing seriously, and others can't criticize them and say we know the probability is too low because you don't know what the processes are. You don't know what the mechanisms are, and there may indeed be mechanisms of self-assembly and self-organization that make it much more probable. There might be such things, but until you find them, it's anybody's guess as to whether they're there or not, and therefore there's certainly not enough reason today to accept it as correct. Are we together? Okay, now there are a few concrete aspects of evolution which I think are worth considering. I don't know how much you know or how much you studied evolution, but there are a few things that I hope I can make clear. Let's go back to the A's and the A stars and the A double stars and the A triple stars, one of the things that set Darwin's mind moving when he read Malthus about population explosion and not enough room for population because population goes up exponentially and food doesn't go up exponentially, run out of food, all that stuff. Most of which is just imagination. Now, because these glitches, 1 in 1,000 by our round numbers, improves, there's going to be competition. And there's going to be competition, and some are going to lose. It is estimated, according to their picture of history, that more than 99% of all species that have ever existed are extinct. Is that a good record? Depends on what you think the record is good for. Maybe the ones that have survived are so much improved that it just means it shows you the great level of progress. Although bacteria are very, very old, billions of years old. They haven't been outcompeted. They haven't been improved. They're just very old. But okay. So now, with 99% of all species extinct, wouldn't it be natural to investigate the extinct species and see how and when they were pushed out by competition? When the new one came in and the new one was faster, better, cleverer, sharper teeth, or whatever it is, and that's how the old one went out? Well, there's a fellow named David Raup, professor at the University of Chicago. He wrote a book called Extinction. He is one of the world's experts in extinction. Kind of maudlin, depressing field, I guess. And he says, now this book is, again, about 15 years old, 20 years old. He says, we don't have a single case of documented extinction on the basis of competition. Not one. Not one. Golly, extinction ought to be, competition ought to be an engine that pushes species out. There are other things that push species out, that's true. Catastrophes, asteroids hitting the Earth and changing the sunlight and all the rest, that happens from time to time, maybe 6 or 7 times in the history of life. But there ought to be an engine of pushing them out by competition. Not one example. Not one. As he puts it, when you see 2 species side by side and one ceases to exist, goes extinct, and the other continues, we can invent scenarios. But of course, we know that had it worked out the other way, we could have invented a scenario also. We could always invent scenarios. We have no solid evidence that this one survived and this one went extinct because it was superior, other than the fact that this one survived, which then is a circular argument. You're supposed to explain why it survived because it's superior, and then you say the explanation of being superior is that it survived, and then you have a circular argument. Why is this? Why is it so difficult to tell? Here's something that I think they don't stress in evolutionary textbooks, but I think it's an extremely important point. You compare 2 species, 2 close species, and there's a difference between them. Is that difference a plus or a minus? Almost always it's both. It's both a plus and a minus. That gives you exquisite flexibility. If the one with this new feature survives, then you can see it had a plus. If it goes extinct, then you can say, see, it has a minus. You're safe either way, which means your theory makes no predictions and it has no content. I'll give you an example. What about our big brains? Is that a plus or a minus? Ernst Mayr, one of the great exponents of evolution, former professor emeritus at Harvard, he's written a number of books which I've read and I've been impressed. I wouldn't say everything he says is correct, but he's a deep thinker and he's a careful thinker and he's got somewhat a self-critical stance. He says certain moves in evolution are very, very useful, and we know because they're tried over and over again. The eye evolved over 40 times independently. Light sensitivity is extremely useful in competition to survive and reproduce, and that's why it evolved so many times. And he says, if the big brain evolved only once in all this time, maybe it isn't so good. Maybe it isn't so useful. Now let's see. We're all aware of the advantages of the big brain, technology and science and cooperation and so forth and so on. What are the disadvantages? Well, for one thing, this big brain has a tendency to in-group conflict called war. And if there were an atomic war in which we all were wiped out, all human beings wiped out, the cockroaches will do fine with radioactivity. They will not be wiped out. They'll survive and multiply and reproduce. Right? So we say, well, the big brain led to their demise. Also, the big brain means that human beings are very slow to develop. A human child becomes independent after a longer period of development than any other species. Longer in absolute terms and longer in relative to lifespan. Well, if you're a toddler walking around defenseless, you are an ideal lunch for a saber-toothed tiger. If we had been simply wiped out by the saber-toothed tigers, we would have said, that's why. It's that big brain that takes years and years of experience to develop into self-sufficiency, and that's what killed them. So the big brain has an upside and a downside. So if we're successful, you could say the big brain was very successful because it had all the plus. If we get wiped out, you could say the big brain was the cause of it because of all of its minuses. Everything is like that. Everything's like that. The tall-necked giraffes, right? There's a lot of criticism of the giraffe story, a lot of criticism. But one of the cute criticisms is this: if being very tall and able to eat the leaves off the top branches, and they bend down also, they can eat for the lower branches also, and make you much more likely to survive, how do you then calculate the difference between the height of the males and the females? There's a considerable gap in the height. Maybe the females should go extinct because the males are eating more of the leaves and there's less leaves left for the females. So over time, the females should go extinct and the whole species should disappear? How about that? Well, if they did go extinct, you could say, look, the males just grew too tall and they outcompeted the females. They don't know to leave some behind for the females. They just eat when they're hungry. And the females just died of starvation. So is the tall neck an advantage? Well, yes and no, sort of, kind of. And it has a plus and a minus. Right? Now, almost everything that you will find has these pluses and minuses. That means to document that this species survived because it outcompeted the previous species is very, very difficult. You take account of the minus side, it's very, very difficult. Okay, one more point, and I'm going to leave it for today. We can start over with the scientific stuff tomorrow, make sure it's got it down. And then we can talk about other things in science. We'll go on to other things as well. We have 5 fingers, 5 digits. Many animals have 5 digits in their feet or paws. Many fish have 5 digits, 5 bones in their flippers. Why is that? Why do you think there's 5 in each? Darwin called this homology. Now, there's a gigantic confusion today, like in the Gemara. It's kind of confusion. What does homology mean? How does it apply? And so forth and so on. I'm going to avoid that. I'm going to avoid that as best I can. The idea is you have in the flipper of the fish, the foot of the animal, and the hand of a human. They're used for very different things. One's used for pushing water, and the other's used for walking on and jumping from. The other's used for grasping. Why would there be 5 digits in each? And the evolutionary explanation is it evolved in fish and was carried along. As fish evolved into animals and animals evolved into man, the 5-digit structure was carried along. And this is evidence for evolution because, presumably, 5 digits isn't ideal for all 3 functions. They are really different functions. That being the case, it's evidence that it was just carried along from an earlier stage. The evidence of evolutionary descent. But this story is subject to many weaknesses. Number one, the last time I checked, it was the genes that dictate the structure of the body, including the 5 digits in the fish and the animals and a human being. So, if the 5-digit structure is carried down from the fish to the animals to the humans, you ought to be able to see a relevant similarity between the genes in the fish that give rise to the 5-digit structure, and the genes in the animal that give rise to the 5-digit structure, and the genes in the human that gives rise to the 5-digit structure. Well, no such analogy is apparent. No such analogy is apparent. What you ought to be able to see is how the fish DNA evolved into the animal DNA, which evolved into the human DNA, since it's the genes that determine the 5-digit structure, and see how that part of the gene is carried along for the 5-digit structure. And that is something which to date has not been evidenced. The 5-digit genes that we have play different roles than the 3, and there doesn't seem to be any analogy between them. That's not good. Number 2, evolution is supposed to be about fine-tuning. There's supposed to be spontaneous variations going on, and then evolution selects out the best design. Well, if 5 digits is really good for fish flippers, which it may very well be, should we imagine that 5 digits is ideal for walking on? Not obviously. So why didn't spontaneous variation and selection get us 4 digits, or 3 digits, or 10 digits for walking on? And same for grasping. Why didn't the same mechanism that causes variations and selection end up with a better designed thing to walk on and a better designed thing to grasp with? Why was the 5 carried? That's the second problem. Then there's the third problem. It's a problem similar to what I mentioned in Ernst Mayr's name. The eye evolved independently 5 times. Similar structures can exist not because they're derived from one another, evolved from one another, but because they're useful. If evolution hasn't changed the 5-digit structure, then maybe it's useful. If it's useful, then why couldn't it come about through entirely independent means? You all know that in Australia there are marsupials, right? Animals with pouches, and that's where they carry their young. Well, Australia's a funny place, and it's separated from the rest of the world, so funny things evolved there. Do you know that there are marsupials in South America also? They're extinct, but there are marsupial animals in South America also. The time scale for this evolution is supposed to be long since Gaia was in fashion. Kind of wonderland. Right? There was convergent evolution because pouches are useful, so they evolved in South America independently of what they evolved in Australia. So the fact that you have similar structures doesn't mean that they have to be derived from one another. They could have evolved. There's a name for it called convergent evolution. They could have evolved in convergent fashion. So the story, when you press it and look into the details and the background, loses a lot of its ironclad appeal, its ironclad solidity, and so it is when you push evolutionary ideas over and over again. Okay, next time we'll start with Age of the Universe and the idea of evolution, and then we'll push on.